Okay, let's look at 2.6, combinations of functions and composite functions. And there's one of the learning objectives that I want you to throw out, which is determining domain and range for composite functions. We're not going to cover that, but we will cover the rest. So what we'll be doing here is given various functions, we want to take some of these functions and perform some operations on them. We'll add, subtract, multiply, divide, and compose. But we first need to understand how to find the domain of a function, so when we get into these and actually find some of the domains, we can do that accurately. So let's talk about the domain of a function when you're not given a graph, when you're given the equation. So you're given an equation, we want to determine the domain, and there are some things we need to consider. The first thing is we will always assume the domain is the set of real numbers, which means division by zero can't happen, square roots and negative numbers can't happen, so we always start with our assumption. Then we'll have to investigate our equations to see if we need to restrict that domain. And just to recall, the two restrictions we work with in the set of real numbers at this point is we can't have division by zero, and we can't take even roots of negative numbers. Division by zero is undefined, and we're not dealing with the complex number system, so that's undefined as well. Let's consider these two functions, one with a radical, one with a fraction. I've got f of x equal the square root of x minus 3, and in stating the domain, I want to state all the values that would work for that function. Well, if I chose the number 1, put that in, I'd get the square root of a negative 2. Well, that's outside of the real number system, so 1 wouldn't work. What if I put in 2? Square root of negative 1? Nope, that won't work. So I've got to find the numbers that will work in that function. They start, suppose I put the number 3. 3 would be okay. 3 minus 3 is 0, square root of 0 is 0, we're good. So the domain for this would be any number 3 or larger. Let's look at the next one. It's a fraction, and we know from our previous discussions that you can't have division by zero, so let's consider this denominator and think, well, is there any x value I could put in that would give me division by zero? What would happen if I stuck in a negative 3 for x? Negative 3 plus 3 is 0. We can't have that happen, so we have to do a restriction on the domain, excluding the value of negative 3. So here's how we'll proceed with finding the domain. First, investigate your function. See if your function involves an even root or if it involves a fraction, because if it does, we may have to restrict it. So let's look at A. Does A have any roots? No, there's no even root. Does part A come in a fraction form? No, there's not any fraction. So if there's no even root and there's no fraction, if I go to state the domain, there's no restriction. So if there's no restriction, our domain is just going to be the assumption, all real numbers, negative infinity to positive infinity. You could write it either way. No even roots, no fractions, no restriction. Let's look at part B. When I look at that, a flag should come up and say, okay, it's a radical. I've got to investigate it further because I can't take even roots of negative numbers. And this one is an even root. So I've got to figure out, well, what numbers will work in this function? Well, instead of trying to guess what they are, here is a procedure that'll work every single time. Take the radicand, which is the part under the radical, which I kind of messed up there, but we'll take this radicand and set it greater than or equal to 0 and solve it. So always take your radicand, greater than or equal to 0, solve it for x, and that'll tell you which values will work for that function. So I'll get x greater than or equal to negative 4. That's my domain. When I go to state my domain, I'm going to state it as all real numbers where x is greater than or equal to negative 4. Or if I choose interval notation, it would be -4 to infinity. But if it's an even root, we want to set the radicand greater than or equal to 0 and solve it, and that will state our domain for us. Okay, let's look at C. Comes up, it's in a fraction form, so that tells me I may have a restriction. Here I have a fraction. So I need to investigate that denominator further. Well, notice that denominator is a quadratic, so we've got to remember how to solve a quadratic. I'm trying to find out what values for x could possibly cause me to have division by 0. So let's work on that denominator. I've got x squared minus 2x minus 3, and I want to find out when is that thing going to be equal to 0. So this turns into a quadratic equation that I need to solve. So let's remember how to solve a quadratic equation. We always start by trying to factor it. So let's try to factor this quadratic. You need to be up on your factoring skills. It factors into x times x. 3 is 3 times 1. -3, +1 gets the factoring of that taken care of. Now if you remember, after you factored, you had to finish solving by setting each individual one equal to 0. So I end up with x equal 3, x equal -1. Those are the numbers that cause me to get a 0 in the denominator. So when I go to state my domain, I have to say x can't be 3 and x can't be -1. That's important. Those are the restrictions that x, or those are the values that x cannot be. If we did this in interval notation, it'll look a little awkward, but I'll put it on here. To exclude those two values, I'd have to say -infinity to -1 with a parenthesis, -1 to 3 with a parenthesis, 3 to infinity. And what this does is it excludes the -1 with the parentheses, that excludes it, and it excludes the 3 with the parentheses. And if you remember, whenever we write more than one interval, in interval notation, we always connect those with a union symbol. If you forget the unions, it's no big deal, but I'm just putting it there because that's actually the proper way to write it. Let's look at the last two. Let's investigate them. Alright, I see a root in D, so a flag should go up. But not a red flag. Actually, a get started flag, because it is a root, but what kind of root is it? It's an odd root. Did we have a restriction for odd roots? Nope, only for even roots. Odd roots will have no restrictions. So its domain is going to be just the set of real numbers. So the root sends up a flag, but it's not stop and find a restriction, it's go, there's no restriction. How about E? Is there any fraction? Nope, no fraction. Is there any even root? Nope, there's not an even root. So if there's no fraction, no even root, what did we say about that? There's no restriction. So our domain here would just be all real numbers.